Let us now see the refraction through a scalene prism, right angled scalene prism. Now I have taken a scalene prism over here, 30, 90, 60. One angle is 30, one angle is 60 and other angle is 90. So a right angled prism, but it's a scalene prism. All the three sides are unequal. So there is a ray P. A ray P is made to fall normally on side BC of a right angled scalene prism. The question is, complete the ray diagram to show how the ray emerges from the prism. So from here, since it's a case of normal incidence, the ray goes straight. From here, the ray goes straight, undeviated, because that's the case of normal incidence. Ray goes undeviated here, reaches here, enters the glass. Now glass is a denser medium and this is air. Air is a rarer medium. This is glass. So this angle is 60, this is 90, this is 30. We draw a normal here. Normal. So the whole is 90. This angle comes out to be equal to 60. One thing we need to know is, or it will be given in the question sometimes, the critical angle for glass is equal to 42 degrees. In most of the cases, the question, it is already given. If it is not given, then you can take it to be 42 degrees. So the ray of light reaches over here inside the glass. Now the ray is going to go from glass to air, denser to the rarer medium. So we can think of a situation where TIR may or may not occur. So look at the angle of incidence now. Angle of incidence is 60 degrees, whereas the critical angle is 42. Angle of incidence here is more than the critical angle. Critical angle is 42 and angle of incidence is only 60. So it is more than the critical angle. So ray cannot go out. It cannot go into the air. Rather, it will get reflected inside, totally internally reflected inside this. The ray gets reflected. Is this 60? Since it is reflected here, this angle is also 60. Angle of incidence is equal to angle of reflection. So I is more than I critical. So TIR. They can ask you, which phenomena occurs on site AC? On site AC you will say TIR. Which phenomena occurs on BC? Refraction. Ray goes straight, one medium to the other. Refraction on BC. It gets reflected here because of TIR. Coming to this triangle now. Let us draw a normal over here. A normal. So this angle is 60. This can be calculated by geometry. This angle is 30. Now this angle is 30. It can be calculated by geometry. This angle is 30. Angle of incidence is 30. So I is less than the critical angle. And consequently, and it's going from denser to the rarer medium. Ray will go out. It will get refracted, bend away from the normal. That's the refracted ray. This is the angle of refraction. This angle is 30. It can be calculated. This is 30. In this triangle, if you see, this angle is 30. This whole angle is 120. This whole angle from here to here is 120. Because 90, 30, 60. This angle is 60. So if this is 60, whole is 180. So over here, this angle is 60. This whole angle from here to here is 120. 60 here, 120 here. So here this angle comes out to be 30. So ray goes out. So you must mention the media. Air, this also is air. Air, glass, air. Mention the phenomena occurring. Refraction. Which phenomena occurs on side AB? You say refraction occurs on AB. BC also refraction only on side AC, total internal reflection of light. So you have to basically calculate the angle of incidence and see whether it is more than critical angle or it is less than the critical angle. Now we have another situation, the same scalene prism, right angled scalene prism, on which the ray P is made to fall normally on side AC of the prism. So since it's a case of normal incidence, it goes straight, undeviated, goes straight from here, goes straight, gets refracted, goes straight, reaches here. Now we calculate the various angles. This is glass, this is air, and this is also air. Rarer to denser and denser to rarer. Let's calculate this angle now. In this triangle, this is 60, 90, this is 30, 90, this is 60. If this is 60, this is 30. So we have got the angle of incidence in the denser medium. Angle of incidence I is less than the critical angle. How much is the critical angle? 42 degrees for glass. Since I is less than the critical angle, the ray will get refracted. It will come out into the air, moving away from the normal. So ray will go out like this, away from the normal. That is the angle of refraction. You can be asked, trace the refracted ray and mark the angle of refraction. Go straight from here, reaches here. So by geometry we can calculate this 30. You must write down all the angles. 30, 60, this is 30. Angle of incidence is angle between normal and the incident ray. This angle is angle of incidence, not this. Many times boys go wrong here. Angle of incidence is the angle between the normal and the incident ray. That's the incident ray and this is the normal. This angle we just found out and that is equal to 30, which is less than the critical angle, hence the ray gets refracted. Now we have another situation in which again we have taken a scalene prism, 60, 90, 30 prism, and air, glass and air. Ray P is made to strike like this. It is made to fall on the side AC, at right angles, 90 degrees. Normal incidence. The ray goes straight. Normal incidence gets refracted, undergoes refraction and goes straight. On reaching this point, we draw a normal and calculate the angle of incidence. 60, this is 90, so this is 30. If this is 30, whole is 90, so this is 60. I is more than I critical because critical angle is 42 degrees. I is more than the critical angle. Angle of incidence is more than critical angle. Ray cannot come out. It will get reflected inside. So here it is. Ray gets reflected here. Again we draw a normal here. Again we draw normal. Now here this ray, this is 90. Now here this is 60. This angle over here can be calculated. Since this is a case of total internal reflection, this is 60. This angle is also 60. That is 90. This becomes equal to 30. 30. Angle of incidence is 30. Now I is less than critical angle. Angle of incidence is 30. Critical angle is 42. So the ray will go out, away from the normal. It undergoes refraction. This is the refracted ray. That's the angle of refraction. So I think that is clear. At this point, refraction, normal incidence, Over here TIR, I is more than critical angle, and then angles can be calculated. This angle is 60, so this is 60. Angle of incidence is equal to angle of reflection. In this triangle, right angle triangle, that is 90, 60, so this is 30. The angle of incidence is 30, which is less than the critical angle. Ray goes out. Let's look at another situation now. Ray P is made incident on side AB of scalene prism. Again 60, 90, 30 prism. Okay, so this ray goes straight. Normal incidence, undergoes refraction here and goes straight. On reaching this point, let us draw a normal and calculate the angles. Over here this is 30, so this is 60, this is 90, so this angle is 30. So angle of incidence becomes less than the critical angle, so the ray should go away from the normal. The ray bends away from the normal. The refracted angle, angle of refraction. So incident ray, the refracted ray, you have to draw like this. Why this goes out? Because of TIR. I is less than the critical angle. The ray goes out TIR. Name the phenomena occurring here. You say, sorry. Refraction. The phenomena occurring here is refraction of light. So because angle of incidence is less than the critical angle. Critical angle is how much? 42. I critical is equal to 42 degrees. Here angle of incidence is less than the critical angle, 30 degrees. And therefore the ray will move out into the air. You could mark the media: glass, air and air. Now let us take an equiangular glass prism. Equiangular means equilateral, all the three angles are equal. Each angle is 60 degrees. Ray P, a ray of light P, is incident on one of the sides of an equiangular prism. And again this light is incident at 90 degrees. Let us name this prism as A, B, C. So light is made to fall on this prism at right angles on the side AB. So let's complete the diagram. Now since it's the case of normal incidence, this ray goes straight. So ray will go straight, unbent, normal incidence. Strikes the side AC. Now at this point we draw a normal. Normal should look like a normal. Draw a normal here. Now looking at this triangle, 60, this is 90, this angle is 30. Now this whole angle is 90, this being a normal, this whole angle is 90, so this is 30, this comes out to be equal to 60 degrees. And that is the angle of incidence. For this point, this is the angle of incidence. Angle of incidence is 60 degree, critical angle is 42 degrees. Since angle of incidence I is more than critical angle, therefore the ray cannot go out into the air. It will get reflected, totally internally reflected. So ray will get in accordance with laws of reflection of light. This is 60, the ray gets reflected here 60, this hole is 90, so this is 30, and 60, 30, so this should be 90. The ray emerges out from side BC at 90 degrees. Normally, normal emergence, normal incidence here and normal emergence here. This is 60, 60, angle of incidence, angle of reflection, and here the ray gets refracted, normally goes straight. So angle of incidence is more than the critical angle. Critical angle is 42 degrees, and TIR, total internal reflection of light. That's how this is to be done. The same numerical can be asked in a different way. The same numerical has been asked at times in a different manner. Here we have another one. Light is made to fall normally on the side AC of an equilateral prism, and this angle is given to be 150 degrees. Now how to solve this? Again, we draw a normal. At this point we draw a normal. Normal should look like a normal here. Now this is 60, this is 30. This hole is 90. From here to here is 90. This much is 30, so this much, this small angle that we have over here, this is 60. This small angle is 60 degrees. Again, let us say the critical angle over here is given to be 60 degrees. Instead of giving, this is a very tricky question, instead of giving the critical angle to be equal to 42 degrees, once the question said the critical angle is not 42, it is 60 degrees. So this angle of incidence is 60 degrees. The ray strikes at 60 degrees here. This angle is 60. So angle of incidence becomes equal to critical angle. The ray should go along the surface. So that angle of refraction is equal to 90 degrees. This is the refracted ray. Angle of refraction is 90. The ray goes along the surface. The same question can be asked, and critical angle is 42, then it will go like that as we did before. It will go down here. But in special situation, a very tricky situation, where instead of giving angle of critical angle as 42, they might give a 60. So here angle of incidence is 60. The ray will go along the edge, around the side refracting surface AC, so that angle of refraction is 90 degrees. That's an important question, very tricky question, which can be asked in two different ways, either like this or like this. Here the critical angle is 42, the ray went down, got reflected, TIR. Here the next question, this angle is, the critical angle is equal to 60, so ray will go along the surface, as we saw in this diagram. So just be careful when what happens of the angles. Please mark all the angles, only then you get the full marks, and also the arrows. Arrows are very, very important. Incident ray, emergent ray, all the arrows must be marked. Let us look at this question now. In this question we have been given a prism which is 45, 90, 45 prism. Two angles are 45 degrees and one angle is 90. Isosceles right angled prism, which we have been doing before also. So in this prism, a ray of light, this is a ray of light P, which is made to fall on the side AC normally, normal incidence. Question is, complete the diagram to show the path of ray as it emerges from the prism. So this being a normal incidence, ray goes straight, strikes this side, unbent. Now at this side AB, on the side AB we draw normal. Normal. Now this is 45, this is 90, so this is 45. Now this hole is 90, being a normal, so this is also 45. Critical angle is 42. You will say I is more than I critical. Angle of incidence is more than the critical angle. Hence the ray cannot go out. It will get reflected inside. So it gets reflected here at an angle of 45 degrees. This is 45. This is the reflected ray. This is also 45 degrees. Now after striking this part, glass over here, let's calculate here. We again calculate over here. This is 45. This angle is 45. So this is 45. This angle also comes out to be 45. Again, it is more than the critical angle. Ray cannot go out. So ray will get internally reflected. So ray gets totally internally reflected. There you are. 45 degrees, and here. Now here 45, this is 45, 45, 45, this is 90. So normal emergence. The ray emerges out normally. Ray emerges out normally. So all the angles should be very carefully marked and arrows should be drawn and reasons given. Here also we say TIR. Which phenomena occurs on BC? Total internal reflection of light. On AC, TIR. Here also TIR. Why? Because I is more than I critical. Here also TIR. Why? Because I is more than I critical. Angle of incidence is more than the critical angle. And here normal incidence. Refraction is there, but it is along the normal. So ray goes straight. Here also ray emerges out straight. It's again the case of normal emergence. Again a very, very important question from examination point of view. Now we have another question here. A ray of light P is made to strike on the surface of water kept in a beaker. Water is kept in a beaker and ray of light P strikes on the surface of water at some angle. So we have to complete the ray of light as it emerges out from the water surface. Now this ray strikes at an angle. It goes here. After reaching this point, from air to water, it bends towards the normal. So we draw a normal here. The ray bends towards the normal, the refracted ray. That is the incident ray. This is the refracted ray. Ray bends towards the normal. Now here we have kept a plane mirror. A plane mirror is kept at the bottom of the beaker. When the ray strikes at an angle, it gets reflected. So here is the angle of incidence I. This is the angle of refraction R. Now this is R, this is also R. I've told you before also while doing the glass lab. This is R, this is also R, being alternate angles. These two normals are parallel. So R and R are the same. The angle of refraction. For this point, this becomes the point of incidence. The incident ray strikes at an angle equal to R, which is equal to angle of refraction. So ray gets reflected in accordance with laws of reflection of light. The ray gets reflected because it is striking the plane mirror. This is the angle of reflection. So that is equal to R also, because angle of incidence is equal to angle of reflection. The reflected ray, when it reaches here, again draw a normal. This is the point of emergence. The ray emerges out, moves away from the normal. The ray emerges out, and this angle is equal to I, so this is also equal to I. Suppose this was equal to 25, so this will also be 25. If this is 45, R will be less than 45. Why? Because it is a denser medium. Ray bends towards the normal. Angle of refraction will be smaller. So ray strikes from here at an angle, bends towards the normal, strikes the mirror, gets reflected, and again moves away from the normal. From water to air, it moves away from the normal. This question has also been asked in ICSE. So having done that, now you can complete the water in the beaker. Complete the diagram. In the end, after you've drawn the various angles and all, in the end you can now show the water. Either use a blue pencil or don't leave it blank. You must write water over there, and like that you must neatly finish the diagram. That's it.